Welcome to perfect square trinomials. So before we learn how to write the equation of a circle when it's not in standard form, to change it from one form to another, in other words, to change it from general to standard, we're going to learn something called perfect square trinomials. And these are all perfect square trinomials. So let's see if you can figure out, I'm going to give you hints, let's see if you figure it out before I tell you why these are perfect square trinomials. Right, so let's take a look at some of these. Well, let's look at the last number. You know what I notice about the last number? The last number is a perfect square. And so that's one thing I notice. Now there is a relationship between the last number and the middle number, the one with the x. Right? So there's a relationship between that constant and the coefficient on the x. Let's see if you can figure it out. All right, so I said that the constants in all of these were perfect squares, right? Because 9 is equal to 3 squared. And 25 is equal to 5 squared. And 36 is equal to 6 squared. Well, now do you see the relationship? Right? And it's the same relationship for all of them. Right? All right, so if you haven't figured it out, I'm going to give you another hint. All right? So what if I took that that square root there? So if I took 3 and 5 and 6, right? And we wanted to change those numbers so that we got the middle term, right? So that we got 6 for the first one, 10 for the second one, and 12 for the third one. What would we have to do to all of those numbers to get that middle term? Well, now I think you can see that you'd have to multiply by 2. 3 times 2 is 6, 5 times 2 is 10, 6 times 2 is 12. And below, I'm going to show you the relationship. We can write it a little bit more succinctly than saying take a square root and then to multiply by 2. So I'd like you to add this to your notes. All right. So the middle coefficient divided by 2 squared equals the last term, equals the constant term. And we're going to use that fact to be able to rewrite equations of circles from general form, which is not very helpful, to standard form, which gives us the center and the radius. So pause the tape right now and put that in your notes. All right? Anywhere on, we're starting off with completing the square part. So anywhere on that page, just put these notes in. All right? Because you're going to want to know this. And not only are you going to want to know this for this year, you're going to want to know it for next year. Right? Because we're going to do things with completing the square next year as well. So just a little hint there. All right, so now let's take a look at some more. And you try to figure it out what's going to go there before I write it in. Now this one's kind of easy because there's a big old hint at the bottom there. Whoops, well, one of us forgot to plug in the computer. No problem. I plugged in everything else. I plugged in all the other cords, forgot to put the plug in. And so it's running out of electricity. Now we're okay. All right, so this one's kind of easy because there's a big old hint at the bottom there. In the following perfect square trinomial, the constant term is missing. X squared plus 14x plus. So to find the constant term, we would square half the coefficient of the linear term. And the linear term is the one with the x. Just the x, no square. All right, so if we take 14 divided by 2 and square it, we'll get the missing term. Let's go back to those other ones and just show that that would work. All right, so let's go back to these and show that if we take the middle coefficient and square it, we get the constant term. All right, so I'll put it underneath here in red. So if I take 6 divided by 2 and square it, we're going to get 3 squared or 9, and that's the constant term. Let's try it with the next one. All right, so we take negative 10, because it's a negative, there's a minus, divided by 2 and square it. That would be negative 5 squared, and that's 25. And that is what the constant term is. All right, let's do it with the last one. Let's take 12 divided by 2 and square it. So 12 divided by 2 is 6, and 6 squared is 36, which is indeed the constant term. So you see that works for all of these. All right, so that's how we're going to find our missing term, because there's a 9, a 25, a 36, they're not going to be there, right? We're going to have to find those, and it's simply as easy as dividing by 2 and squaring. All right, so let's do a few practice ones. Practice in terms of just finding the missing constant. All right, once you got the missing constant, the rest of it's actually pretty easy. All right, so we want to create a perfect square trinomial. All right, so you try to think about it, you figure it out before I write it down, okay? All right, let's look at the first one. All right, so if I take, so on all of these as a reminder, we're going to take the middle coefficient, divide it by 2, and square it, and that will equal the constant term that we're missing. All right, so let's look at the first one. All right, so we have 20 is the middle term, divided by 2. Let me rewrite that. It's kind of messy and it's kind of low. 20 divided by 2. If we square that, that's our missing constant term. So 20 divided by 2 is 10, and 10 squared is 100. And that's our missing term. Now it's a perfect square trinomial. And I'm going to tell you what's special about why it's called a perfect square trinomial. Because at this point, other than the fact that it's got a perfect square at the end, it's not really apparent why it's called a perfect square trinomial. All right, so I'm going to take the second one. All right, so I'm going to take negative 4 divided by 2 and square it. Negative 4 divided by 2 is negative 2. Negative 2 squared is 4, and that's our missing term. Notice that last term is always going to be positive, because when you square a number, whether it's positive or negative, it turns out positive. All right, and then the last one. All right, so 5 divided by 2, and we're going to square it. Well, 5 divided by 2, that doesn't simplify. Don't make it 2.5. That will just make it harder. All right, just keep it 5 halves. All right, trust me, keep it 5 halves. And to square a fraction, you just square the numerator and square the denominator. Now, if this reduced, I would reduce it. But 5 and 2, they have nothing in common. So we'll square the 5, and that's 25. Square the 2, that's 4. And that is our missing term. And all of these are perfect squares. Now, the other important thing, besides finding the missing constant term that makes it a perfect square, is to be able to factor. And the factoring is really easy because you're going to do the same thing each time. All right, so this one is done for you, and then I'm going to do a few together, all right, just so you get the hang of it. All right, so this is a perfect square trinomial. It was the first one on the last page. We'll do the other two on the last page. On the next page. X squared plus 20x plus 100. Now the factors are x plus 10 times x plus 10, or x plus 10 squared. Notice they're the same factors. So if we are multiplying something by itself, this is a perfect square, which is why this is called a perfect square trinomial. We could rewrite that into a perfect square. Right? So if you multiply something by itself, it's that thing squared. Right? So that's what makes it a perfect square. It's a trinomial because there's 3 terms. Right? So perfect square because when we factor it, it's a perfect square. Right? It's something times itself. So it factors to a perfect square. Right? That's the square part. And then trinomial just means 3 terms. So that's why it's called a trinomial square, or a perfect square trinomial, 3 terms. All right, so the little helpful hint, there's 2 of them. I like my second hint better, but you use whatever you want. You use this hint or the next hint because they will work out to be the same number, right? And they're both mathematically correct. So shortcut number one, after you find the missing number, the missing number is the constant. To factor it, just take the square root of it. And so that means it's going to be x, and then whatever the sign is. If this is a plus right here, if that's a plus, that's a plus. If that were second term were a minus, then it would be a minus. So whatever the sign is, it's going to be x plus or minus, and then it'll be the square root of c, x plus or minus, whatever the sign is, times the square root of c. So you just take the square root of the constant, which is equal to x plus or minus the square root of c squared. Right? So you just have to take the square root of the last term, and then it's always going to be x, whatever the sign is, and then the square root. This is the other helpful hint, and it works the same number. That's why it doesn't matter which one you use. So this is shortcut number 2. So it's telling you what to do for this part. All right, so then just take half of the coefficient of x. It's the same number. Right? So that means this would be x plus or minus b divided by 2, because this number right here is b. This is a. A is the coefficient on x squared, which is 1. B is the coefficient of x, which is 20. And c is the constant term, which is 100. Right? So x plus or minus, whatever the sign is of b, x plus or minus b divided by 2, x plus or minus b divided by 2. And the sign, regardless of which method you use, is the sign of b. Right? So the plus or minus part is the sign of b, which is the coefficient on x. All right, so let's take a look at how it works for this one here. So if I'm factoring this one, this could be x, this would be a plus because the b is positive, x plus, so this is method number 1, right? So this is number 1. Right, so if I use method number 1, I'll color code it. Right, so I wrote it in red, I'll write it in red here. Right, so this would be then x plus the square root of 100 times x plus the square root of 100. Square root of 100 is 10. And you don't have to show each one of these steps. You can just literally write the last step. Right? This is just to show you. Right? So the square root of 100 is 10. And that's the same as x plus 10 squared. You see? So you can, once you know the pattern, you can just go right to x plus 10 squared on the last step, right? So I will always write this intermediate step in here. I'll always write that step in for the notes because I don't want to lose you. You can leave that step out, though, if you're solving problems. All right, so let's use this method number 2. So this one was method number 1. Right, this is method number 2. I tend to use method number 2. Right? So then it would be x plus 20 divided by 2, x plus 20 divided by 2, which is the same as x plus 10, x plus 10. Right? So in my head, I'm doing 20 divided by 2. I probably am not going to write 20 divided by 2, and I'm probably not going to write the square root of 100. I'm probably going to just think in my head, oh, 20 divided by 2 is 10. Right? And that's, no matter what, though, it's x plus 10 squared. So you see, either way, either you take the square root of the constant term or you take half of b, you get the exact same number. That's what's great about this. So let's do a little practicing, and we're going to factor all of the ones that we had up here and over here. And you'll see we can do them really quick. All right, so I'm just going to write them down on my board, on the actual board, so that I can remember them. X squared plus 6x plus 9, because I didn't think about doing this initially, and I'm like, oh yeah, we should practice these. Usually I go right to working with the circles, which is actually a little more involved, just a little bit, than just doing the factoring, just coming up with the term and factoring. And so this time I decided, you know, let's just practice before we start writing equations of circles. Let's just practice the factoring. And did I get everybody? We already did the first one here. So x squared minus 4x plus 4. And we'll even do x squared plus 5x plus 25 fourths. All right, so we're going to factor 6 of them all together. All right, you don't have to put this in your notes unless you want to. All right, I'm going to put it right after this page, and you'll see they don't take that long. All right, the first one, x squared plus 6x plus 9. Right. Tell you what, there's 6 of them. I'll do half of them, method 1, and half of them, method 2. I will write all the steps because I want you to understand in the process. Right? You can go, though, from this to the factored form because it follows a pattern. You don't have to show your work. But I'm going to show my work just so that you can understand what work I'm doing in my head. Right? So I'm going to use these ones. Oops. This is going to all be method 1. Right? And that method 1 was the x plus or minus the square root of c squared. All right? So this would be then x, that's a plus right there. So x plus the square root, c is, or maybe I should write that in there. I'm kind of assuming you all know a, b with that, which term on the quadratic trinomial there is a, and which one is b, and which one is c. But what if you don't? All right, so a is the coefficient on x. Is not x squared. It's not going to come up at all in this. B is the coefficient on x, and c is the constant term. Okay, so we're using the first method, which will be the square root of the constant term. Right? So then this would be x, and this is a plus. I'm going to get rid of that line underneath it. It makes my plus look like a plus or minus. Right, so that's a plus. So I'm going to write x plus, and then square root of 9 times x plus square root of 9, and square root of 9 is 3. There's 2 of them, so I can just write it as x plus 3 squared. Right? You can go right from the problem right to that. Right? You don't have to have those 2 intermediate steps unless that helps you. Okay? I'll just do it for notes. But on homework, you don't have to show all these steps. You can do them in your head because they're the same each time. All right, so now let's do the next one. X squared minus 10x plus 25. All right, and so a is the coefficient on x squared, b is the coefficient on x, and c is the constant term. All right, and we're using the first method, so this will be x, that's a minus. So the 10x is negative, so I'm using a minus. It's whatever b is, right? Regardless of which method you use. Right? C is always going to be positive. Right? So x minus, and then square root of 25 times x minus square root of 25. Right? So that's going to be, square root of 25 is 5. So x minus 5 times x minus 5, which is x minus 5 squared. That's all there is to it. Right? Let's do another one. One more, and then we'll use method 2. X squared plus, I don't know why I put parentheses there. You don't really need it. X squared plus 12x plus 36. Right, so a is the coefficient on x squared, b is the coefficient on x, c is the constant term. Right, and so when we factor it, it will be x, and then b is positive, so it'll be plus x plus square root of 36 times x plus square root of 36, which is x plus 6, x plus 6, or x plus 6 squared. Right? And like I said, you can go right from the question right to the factoring, the factored form. Because once you get the hang of it, you can do it in your head. All right, let's do the same thing, but now let's use method 2, which is x plus or minus Oops, I'm stuck. I have a recording box, and I can't seem to write where the recording box is, so we're going to move it out of the way. You can't see that recording box, but it's there. Still can't seem to write over here. Okay, there we go. All right, so x plus or minus b divided by 2 squared. All right, so we have for the fourth one, x squared plus 14x plus 49. So that's going to be, so a is the coefficient on x squared. It's not going to matter. It's always going to be 1 when it's a perfect trinomial. B is the coefficient on x, and c is the constant term. Right? So now I'm using x plus b divided by 2. Right? So I have x. No matter which method I use, the sign here is the sign of b, so it's a plus. And then this would be 14 divided by 2, x plus 14 divided by 2. 14 divided by 2 is 7. X plus 7 times x plus 7, which is x plus 7 squared. Right? And then 2 more. X squared minus 4x plus 4. Right? So a is the coefficient on x squared, which is 1. B is the coefficient on x, which is negative 4. And c is the constant term. Right? So it's going to be x. B is negative, so it's going to be minus x minus 4 divided by 2 times x minus 4 divided by 2, which is 4 divided by 2 is 2. So that'd be x minus 2 times x minus 2, which is x minus 2 squared. And then the last one, which is the tricky one because it's got a fraction, x squared plus 5x plus 25 fourths, but it's not really because, oops, 25 fourths, the fraction is the constant term, so we're not really using it anyway. And taking the square root of it wouldn't have been hard. And so a is the coefficient on x squared, b is the coefficient on x, 5 there, and c is the constant term. So this is going to be x, b is positive, so it's going to be a plus, and then 5 divided by 2 times x plus 5 divided by 2. Now you can't really simplify 5 divided by 2. Don't write 2.5. Just leave it as 5 halves. So there's 2 of them. That's x plus 5 halves squared. And just to show you, we'll just kind of go through. We won't write it down, but we'll just go through it and show you that you get the same answer no matter which method I used. Right? So on number 1 there, x squared plus 6x plus 9. If I had taken half of 6, that's 3. So I still would have gotten x plus 3 squared. Half of negative 10 is negative 5. So that would still give me x minus 5 squared. And half of 12 is 6. So that still would have given me x plus 6 squared. If we did take the square root method, the square root of 49 is 7. So it would be x plus 7. Square root of 4 is 2. And then b is negative, so it still would have been x minus 2 squared. And the square root of 25 fourths is just, you just take the square root of the numerator and square root of the denominator. So that's 5 halves. So you still would have had x plus 5 halves squared. So you see, it doesn't make any difference which method you use. Use whichever method you like. All right. So we did a little practice with factoring. On the practice, I'm just going to have you be able to fill in the missing value from a perfect square trinomial and do a little practice with some factoring. All right. Thanks for watching. I believe this is my last slide for this video. I think the next one will be, yep, the next one is in the next video. So thanks for watching and bye for now.